Hi everyone, I just wanted to put together a quick video going over some not majorly commonly missed questions, but where at least maybe 20-ish% of people miss, so more commonly missed than questions you guys were able to successfully answer. For the most part, everyone did a really great job in the terminology section. There is a note I wanted to make it was a comment that I made in one of the news items on the main page, and that was what standard scores are. You're supposed to list all of the standard scores. I think it was this one, which terms in the word bank represent types of standard scores. So this was one of those questions where there should have been 4 blanks and there were only 3. So technically everyone got a free point just because of that. But the standard scores that were in the actual term bank should have been z-scores, coefficient of variation, percentile, and then I believe it was z-score for skewness. Okay, so if you had any one of those 3, you should have gotten full points for that. The next one I wanted to go over was for the triathlete question, that was which 2 variables seem to have a relationship. You should have made scatter plots kind of looking at the relationships between these variables. So between cycling time and swim time, you can see there's kind of no real pattern, no real relationship. I think quite a few of you put 5K time and cycling time. And again, there's not really a relationship here. If you look at 5K time and swim time, however, you can see there's a pretty distinct relationship, right? As swim time increases, their 5K running time decreases. Okay, so if you made scatter plots, didn't really matter what variable was on the x versus the y-axis. You should have still gotten a similar shape with regards to the variables you were using. So that kind of covers that one. For the high school sports, I'm going to toggle over real quick. There we go. Okay, you had this chart, right, that gave you gender, sport, and year. So in the first one, this is kind of a test of how well you're able to organize your or use the filter function in your data, so organizing data basically. The first question I wanted to review is what is the mean peak power output for all seniors? So the best way you would have done it, or best way you could have done this, is to highlight and apply a filter to all of these columns of data. And then we would have sorted that data. We would have sorted that data by, let me delete these real quick so they're not applied, by year, right? Because we want all seniors clumped into one. And let's say we're going to go from largest to smallest. Okay, so that way we have all of our seniors up top. Right? And then our mean power is just going to be the average of everyone who has a label of 4, right, in this year column, because 4 represents seniors. So the average you should have gotten is 885.56, right? You're rounding to the nearest hundredth, I believe is what I listed here, so that should have been the answer that was provided. In the second part of that question, you were supposed to find the mean and the standard deviation for male sophomore soccer players. So I have that indicated here. And this one you would have had to use a custom sort function. So first you want to, let's say we're going to sort by gender, because male. Okay. And then in this case, if we want to keep our males on top, right, they were listed by 2s. So in our filter, maybe we want to do largest to smallest. Okay, And then we want to filter by year. Okay, sophomore kind of in the middle, so it doesn't really matter with this part. And then we want to, oh no, this didn't change. Gender, largest to smallest. There we go. And we'll go by year. And then let's say we calculate it by sport. And in this case, soccer was kind of in the middle as well. So again, it's, I'm just going to keep that smallest to largest. That may make it easier. So from here, again, we're doing gender, year, and then sport. And it's important to remember kind of the combination of values that you're looking for. So we want male. So in the gender column, we're looking for 2. I have a labeled 2. For sport, it'll be soccer, which is 3. And for year, it'll be 2. So the kind of label combination we're looking for in these 3 columns is 2, 3, 2. Right? So when we calculate the mean, and this range might have changed. I'm hoping it stayed the same. You're gonna scroll down. Yeah, it did change. I was thinking that number didn't look quite right. Okay, so you're gonna look for the grouping, right? 2, 3, 2 would mean male, soccer, sophomore, right? With the way that these columns are labeled. So you would take the mean, right, of those clump of cells. That would give you 758, and then I think my standard deviation probably shifted too, because I've sorted this so many different times. And when I undid that function, when I came in, it probably messed it up. So the mean should have been 758, and the standard deviation should have been 50, approximately. Okay, so that kind of covers those ones. The other question I wanted to go over was sport teams. So in this one, the main question I wanted to look at was kind of how you would describe this shape. Because most of you pretty much got the concept. There were just a bit of discrepancies in how you found your answers. Several of you said that you looked at a histogram. And I gave you partial credit for that answer, but that's not a reliable way to find if we have skewness or kurtosis or discrepancies in the shape of our distribution. So what you should have done is calculated your z-square of skewness and your z-square of kurtosis, right? I think a couple of you might have stopped at the skewness and kurtosis without dividing by the standard error. And so then you probably would have been led to believe that the distribution was normal, right? But remember, when we're comparing a sample to a population, we have to involve some measure of standard error, and that's going to give us what our sample would look like if we overlaid it on top of a population. So in this case, the data were negatively skewed, right? And I had answers both for SPSS and Excel, so you can kind of compare the values that you got there, but we would have had negative skewness and no kurtosis. So if you just put negatively skewed and then you gave a reasoning that, if the values were between plus or minus 2, then we would accept it as normal. If they were outside plus or minus 2, then we would say we have skewness or kurtosis, right? So if you had that justification, you also got partial credit, even if you didn't have the right numbers. So this one was graded. I'm trying just to see, do you know how, to evaluate the shape, and what was the accuracy in evaluating the shape? The next question I wanted to go over, this was the one that actually gave back to you guys point-wise, and that was finding the percentile of a student who is able to complete the mile in 7 minutes. Okay, and I'm pretty sure I know what the common mistake was, and that was that you guys probably, let me actually do this first. In your equation, right, we're obviously looking at mile time, but a lot of you had a percentile of 27%. okay? And I'm guessing that you inputted values that were less than or equal to 7, okay? Well, remember, if we're looking at time in particular, when we have our distributions, right, with our mean in the center, at some given time, remember, we're looking at all of the values that are at or worse than. In this case, lower times would be on the high end, right? Because those are like the fastest people. Higher times would be on this end of the distribution, however, right? So when you're looking at a percentile for someone who was able to perform the mile in 7 minutes, that's going to be wherever 7 is, let's say it's here, right? 7 minutes, and then everybody who performed worse than that person, okay? And that's how we get 73%. I'm going to turn that off before I forget. I wanted to go over this kin major question because I feel like it's one that either student, you get the whole thing or you don't get the whole thing. Most of you actually got portions, even if you were able to guess, and I tried to word the question slightly differently this year so that it wasn't kind of an all or nothing, because it is a nice chunk of points that is in this area. So the first one was the exercise science question, right? So you were given a list of different means and standard deviations for different kin major groups, right? So the first one you were looking at, exercise science, the mean was 43.1. The standard deviation should have been 4.5. So there were a couple of acceptable answers that you could have had for this portion. You could have put 0 as the mean or x as the mean, and then gone 1, 2, 3, negative 1, 2, 3 if you're listing by what you would expect as standard deviation, so kind of this type of labeling. Or you could have found the actual values that existed at each of these standard deviations, in which case this would also be acceptable. I also included if you labeled it by percentile. So go back to the normal distribution or the normal curve lecture, there was a bar or a bell graph, right, or bell curve that had the empirical rule on it, and there were different percentiles or percentages of the population that would exist in between certain standard deviations. So if you were adding those amounts in, that was also an acceptable way to label things, where the mean would have been the 50th percentile, above the mean would have gone up towards 100, and below the mean would have gone down towards 0. In any way that you labeled that. So there was a little bit of leeway with how you guys answered. You wanted to find the percentile for someone who was greater than 47. Okay, so we know visually 47 is going to land between the mean and the first standard deviation. Okay, so that's why I labeled that question in a certain way so that this last part, right, given the distribution you created, indicate the area. It would have been at the mean, or in between either, what was this, A, B, C, D, right? E technically would have been the closest one, but I tried to keep it a little bit variable that way, estimation wise, if you guys thought, whatever. But if you put, it should have been A, B, C, D, E. Anything greater than E pretty much kind of included most of what this percentile was looking for. Typically on the exam I would have asked you to physically shade in the area, but we can't do that in Beachboard, so it's a little bit more difficult. But you should have, that portion should have been easy just based off of the numbers or the distribution you created. In this case, you're supposed to find a z-score because you're estimating right? The percentile of a given person. So in this case, I have couple different rounding errors, right? If you kept it at 8.7 or 0.87 or 0.86 and didn't round, these percentiles came off of the graph, these percentiles are calculated from basically like what would be included at these given scores, right? And then the probability, so this is, back up a second, I'm sorry. The percentiles are what would have been given in the z-score table, right? Because z-scores that are positive are going to return a percentile of 50% and above, right? Because most positive ones would be anything from this end over to the left, right? But since we're interested in, say, we're in between kind of the mean and the first standard deviation, so I'm going to say, oh, like right here. The z-score would have returned this area, right, which is the 80% that we see. But the area we're actually interested in is on this end. Okay, so we would have done 100 minus the percentile, or 1 minus if you kept it as a decimal, right? So it should have been somewhere close to 19. Similarly, for the athletic training question, again, the labeling was a little bit similar to how I graded this one. So you could have either calculated the actual numbers, or you could have calculated or put, like negative and positive standard deviations around a mean, or the actual percentiles from the empirical rule, in which case the answers for labels on this graph would have been the same as they were on this graph. But similarly, you would find the z-score for 42.7, which is our first point of interest, and then you would have found the z-score for 55, right? This should have led you to certain percentiles on the given z-score tables, and then the probability is what would exist between the two, right? So in this case, we're looking at, and I apologize for my bad drawing, okay? In this case, our mean is in the center, right? We have a z-score for 42.7. You could have either evaluated it by standard deviation, so it would be between 0 and 1, or 0 and negative 1 standard deviations, versus 55 would have been between 0 and 1 standard deviations, right? So let's say this is our negative 1 and this is 1, okay? Negative 0.3 would have been closer to the mean. So originally I had D, right? If we're counting from negative to positive, it was A, B, C, D. Some of you put C, and I accepted that as well because it technically is within this range. The instructions were to, pick the letter that was closest to, but it's okay, right? And then 0.89 is closest to E, right? So if you put between D and E or between C and E, it was acceptable, right? But basically this is the area that we're concerned with. And we get that by, if I change colors here, okay, percentile of 42.7, right? This is returning the percentage from here over, right, or to the left, which technically we're not really concerned about, okay? In the other case of 55, the percentile would have returned the area from there to the left, right? So in order to get this center part, right, we would have divided the green area, which is 81.33, minus the blue area, which is 37.83. Okay, so let me turn off my drawing, right? So you should have gotten, right, D4 minus D3 in this specific instance, or the percentile at 55 minus the percentile at 42.7. So hopefully that makes a little bit more sense. Lastly, I wanted to talk about the energy drink question. There was actually a problem um, when I copied this over. I had changed the wording of this question, and this is what it was supposed to look like. And I've since changed it that way for next semester. It's correct when I copied the test over. But in your guys' version of the question, it wasn't this broken down. So it would have asked you, uh, still comparing the three different energy drinks, but also looking at time of consumption prior to a workout. So, acceptable questions in this area, they were automatically graded wrong. So it should have been type of energy drink, right? Or time of consumption. That was not included. With the new version, I only had one independent variable, so it wasn't a big deal. In either case, if you have this question versus the one or the version of the question that you guys got, both a type of energy drink as well as time of consumption would have been nominal type data. Okay. For the dependent variable, you can see I tried to get as many types of values or variable names that you guys would come up with. It should have been 1RM squat or squat performance, and that would have been ratio type data. Okay, and then the hypotheses that would have resulted should have been the null hypothesis. Remember, that's the one we always statistically test. Okay, because it's true until you prove it untrue, right? And then in this case, for the question version you guys got, it should have been type of energy drink and time of consumption have no effect on squat performance. Okay, so hopefully that clears that one up, just because when you guys go back into your exam, I'm not sure if you'll have the original question or the version that I changed. So if you have any additional questions or I didn't touch on a question that you missed, please give me or shoot me an email and I can help discuss reasons why your quiz was graded the way it was. But overall, you guys did a really fantastic job. I'm really impressed with your performance on the exam. So kudos to you.